Alright guys, so here we go. We're starting to wire it up in this part. So one thing I want to point out is that we are not using a MOSFET anymore. I said in the last video that we might not use it, and I happen to have this 2N3904. So it's an NPN bipolar junction transistor, and it'll do the same trick for us. So the only difference is that it's a bipolar junction transistor, it's not a MOSFET. So basically, instead of gate, drain, and source, we have emitter, base, and collector. If we look at it right here, it's this three-legged device, and it goes from left to right, emitter, base, and collector. And the base is where we're going to control the voltage from. So basically, here's the wires that go to our garage door opener. I'm not I ran them all the way from the garage door into my room, because my room is right next to the garage. So these wires do actually still go to the garage door opener. If I were to touch them right now together, the garage would open. You'd probably hear it through the wall too. But anyways, so as we remember, this was our positive voltage, and this was our negative voltage, or our ground, if you will. So what we're going to do is, because this is an NPN transistor, our ground, or that negative voltage, this is about, we read about 17 volts on the meter, so our negative voltage is going to go into the emitter of this transistor here. So we're going to put it in the emitter. And it's just going to go straight into that emitter, just like this. So I have now the garage door opener plugged into the emitter, and then the other wire is going to go into the collector. So this is going to complete our circuit, just like that. And basically, this is basically a switch now. So we have our negative wire or ground going into the emitter, and our other wire going out the collector. And it will connect these two, or pretty much connect them, create like almost zero resistance between them, if we were to apply a positive voltage to that base pin. So we're going to do that using the Arduino. Now here's our Arduino. I have uploaded the code that I made in the last video. It's uploaded to this board and it's ready to go. Here's the Ethernet shield. In fact, I have an Ethernet cable here handy, and we'll just plug it right in. So here we go. And then what I'll do is I'm going to go ahead and take this 10K. So this is a 10K resistor. It's a 1% tolerance. If we can look at it here, I don't know how well it'll focus on that. There it is. So it's hard to see the colors. It's hard to see them even in person, but take my word for it. This is a 10K 1% resistor. It's not a 5%, so it doesn't look like a normal resistor. But anyways, we'll take this from our base, and we'll just go off over to here. So this is a 10K to our base. And then we'll also create this 4K7. Or I'm sorry, this is not a 10K, this is a 1K. If I've been calling it a 10K this whole time, I'm sorry about that. This actually is a 1K resistor. I have some similar ones that are 10K, but this is a 1K. And then we'll have this 4K7, so this is 4,700 ohms, 4,700 ohms. And we will also take this to the base. But it's also going to go to the emitter. So this 4,700 ohm resistor is going to go between our emitter and our base. And what this does is this is a pull-down resistor to ensure that this transistor doesn't latch. Now, these transistors usually don't latch, bipolar junction transistors, but it's usually always a good thing just to have that pull-down resistor just to ensure that it doesn't latch. And then what we'll do is we'll take this red wire, and we'll go from our 1K to pin 6 on the Arduino. It's actually going to come off the Ethernet shield because it comes up the jumper. So we have it plugged in here on pin 6. Don't know if you can see this, but it is going in on pin 6. And I'll get a close-up footage of everything when it's done. I'm just kind of showing you guys where I'm plugging things into right now. But we'll get some really good close-ups when it's done. And I'll show you guys again how everything's wired real quick. And we'll just run through it and then we'll fire this thing up. But anyways, so it's going from pin 6 through the 1K to our base, and we have our 4K7, our 4,700 ohm resistor, going from the base to the emitter, which is ground, and that just pulls it back down to 0 volts, and that was going to the wrong pin. There it goes. So basically, we have our power that goes into our base from the Arduino when we apply that signal, and then it pulls it back down to 0 from this 4,700 ohm resistor. And then, of course, there's not going to be any power flowing from this Arduino into the base of this without connecting the grounds together. So we have to have a common ground between the two guys here. So we'll go ahead and plug this into the ground on the Arduino. So its ground will be referenced to the ground on here, which is again the emitter. So we'll tie the ground on the Arduino to the emitter on the transistor, which is also that black wire, the ground coming from the garage door opener. So now 5 volts will flow into the base of this transistor. And then what we'll also do now is, I think that's actually about it. So we'll go ahead and take a closer look at this, and then we'll test it real quick to see how it does work. So let's go ahead and take a closer look at this setup. Alright guys, so now I do remember what I forgot to mention, and that was this one wire going to pin 36. Remember, this was our feedback wire. Like I said, this is what we would use to tell the actual state of the garage door opener. Now I'm not gonna lie, I didn't go through all the trouble of actually hooking up a switch to the garage door opener. I don't really have any momentary switches or any, bump switches or anything laying around that I can use to hook up to the garage door opener, nor do I want to go in there and rig one up, but I would assume you guys are smart enough to go and put a switch in there. So basically what we're doing is, this is our janky switch, and I'm manually switching it myself based on the position of the garage door opener, as if it were connected to an actual switch. But yeah, it would behave exactly how we wanted it to if it was connected to a switch and the garage door did flip that switch, but I'm way too lazy to go out there and actually hook up a switch, nor do I, like I said, I don't have a switch to go out there and hook up. So I'm just using this jumper as a switch. So with that said, let's go ahead and just take a closer look at this circuit. One thing is worth mentioning that I did flip out. You can see that that 4K7 resistor there is out, and I did replace it with a 10K. The 4K7 just wasn't working out. It was a little too low, and the circuit wouldn't actually work. So let's take a look at it. So here's our 3907, a 3904 transistor, the NPN, and we can see that the first leg, the emitter, we have that negative side of the garage door opener, and that negative leg on the Arduino. So the grounds are tied together, and then we have that 10K going from one leg on from that emitter on that transistor to the base, and that's our pull down resistor to ensure that this guy here ensures that this transistor does not latch and that it does turn off when our signal is turned off. Then our collector pin goes out to the positive pin on that garage door opener, and that connects our circuit together. It basically is like a switch, an electronic switch. And then we have our 1K resistor. This is a 1% resistor, so it looks a little different. And that goes from our base to our signal wire coming from our Arduino. This is our pin 6 here, and that just ensures that we don't have too much current flowing into this transistor. It protects our chip on our Arduino from, drawing too much current, and also protects our transistor from, pulling too much current and damaging itself. So we can see that the red wire goes into pin 6. That's coming off our Ethernet shield because it covers up pin 6. So we just use the pin 6 from the Ethernet shield header. Then we have our grounds tied together through that ground jumper there. That allows a full loop for our current to flow through our signal wire into the transistor. If we didn't have this ground wire there, it would not work. And then we have, of course, like I said, this going into that pin 36 there. Now that is, like I said, a weird pin number. It's just a really high number, and you won't have it on a lot of boards. Only the Megas are going to have those. So if you don't have pin 36, you can use any pin number you want as long as it's just a digital I/O, and you can use pin 2, 4, 6, 8, or 1 through 4. It doesn't really matter. Just use any digital I/O pin, and you can do the same thing with this. And right now it's connected to 5 volts on the power, and we can see that right there. It's connected to 5 volts, and that's just acting as a switch. So it's either going to be 5 volts or ground. Now, if you were to hook this up professionally through a switch, what I would do is I would have a pull down ground resistor, probably just a 10K. So I'd have a 10K between ground and pin 36, and then what I would do is I'd have this switch on 5 volts, and it would go to straight to pin 36. And so that would bring it up to 5 volts whenever the switch was connected. And when you broke it, you'd have your 10K resistor pull that pin 36 down to 0. And that's the equivalent of me taking this wire out and switching it between 5 volts and ground, which is acting just as a switch to tell the position of the garage door. So what I'm going to do is I'm just going to go ahead and we'll open up a web browser here. And I will we'll go ahead and open up our web browser. And I'll open up the IP address that we set, which was, here, let's go back into auto, 10.0.0.120. So we'll access that, where's my mouse? Here. So 10.0.0.120. And this is it. So it was, like I said, originally an LED controller that we've modified. So we can see it says on the page the garage is open as soon as we access the page, and that is because the jumper here is set to the 5 volts rather than the, let's go back into manual mode here. It's set to 5 volts rather than the ground pin. So if I were to go to the ground pin here and I were to switch this, I'm going to go back into auto. If I were to switch this pin to ground over here and then refresh this page, so whenever I refresh it, now it's going to say, hey, the garage is closed, okay? So it's using the state of pin 36, whether it's high or low, to tell the state of the garage door opener, to tell whether it's open or closed. And like I said, we could just do this using a button in real life, or a switch. We can have the garage toggle a button or a switch, and we can use that to determine the actual position of the garage. So if we go ahead and put it back over here to 5 volts, we refresh the page, and it says, hey, the garage is open now. So now we've also coded it in such a way where I hit this open button, and you can see that it's not opening the garage. And you guys will probably hear it. I'll go out there and show it to you guys on my iPhone just to prove that it works, but here's the whole circuit running here. Whenever I hit a button, you can see the lights on the Ethernet shield flash. Like it's getting a signal, I guess you could say, not really a signal, but it's receiving packets from this client here, this computer. But it doesn't actually open up the garage. Why is it not opening the garage? Well, because the garage is already open, and that's what our code does. We coded it so that if the garage is already in the state that we're clicking it to go to, it's not going to toggle it. Okay, so now if I were to go ahead and I were to switch it, and it thinks that the garage is now closed. Okay, the garage is closed, so let's go ahead and refresh this page. You don't even have to refresh it, actually. It shouldn't, but we'll try it. You should not have to refresh it, but now if I click open, we hear the garage door opening. And it just finished opening. I don't know if you guys could hear that. The garage is literally on the other side of my wall, but you guys probably could hear it just open a second ago. But just to prove to you that it's open, I'll go out there and show you that it's open, and we'll actually do this whole thing from my iPhone right in front of the garage, just to show you guys that it does open and close with this controller. But also, we can see that it still says the garage is closed. Why doesn't it say the garage is open? I just clicked open, so why isn't it opening? Or why isn't it saying that's open? Well, that's because, again, we're not using an actual switch, so it's not updating in real time. I have to actually manually do it right now. So now, if I were to refresh it, the garage, it thinks now that the garage is open. If I refresh it, and there you go, so it says the garage is open, and it actually is. And this would change by itself if we did have a switch, but again, I just have a little wire jumper here to simulate that. But in an actual situation, we'd have a switch there, and we could use that to make it so that these buttons are idiot proof, and if we push them, if the garage is already open, which I just opened it, and I push it, hey, the garage is not going to open. You know, it's sending the command because I can see the lights on the Arduino blinking, but it does not open it, no matter how many times I click it, because it knows that, hey, the garage is already open, so don't open it, you idiot. But now, since it thinks that the garage is open, if I hit close, you guys can probably hear it closing in the background. So it knows the state of the garage, and it will open or close it based on that state. So let's go ahead and I'll pull this up on my iPhone real quick and we'll take a quick look at it actually working in action. Alright, so I have it here on my iPhone. Don't know how well you guys can see this. Probably not very well, but anyways, so we have it right here. It says the garage is closed, and as you guys can see, it actually is closed, but that's not going to change even if I do open it. The reason being, again, because we don't have the button actually hooked up. So here we go. We're going to go ahead and hit open because the garage is already closed. Let's just go ahead and I'm going to hit close just for kicks here. And we just tap close, and we can see that it changed the button, but it keeps defaulting to open, and that's because and it's not actually doing anything, and that's because it knows that the garage is already closed based on that switch, that feedback that we give it. So let's go ahead and hit open now, and it opens up the garage door. And here we are again back at this button, and just to prove to you guys, we have the whole thing going into running into my room here. Anyways, so we'll push that button one more time, and the button still works just perfect as if we never added the circuit. So we can use either the web control or the button to still control the garage door opener. So we did not lose the functionality of the button throughout this project. Alright guys, so that's pretty much this whole thing here. That's pretty much the end of this project. Just kind of wanted to show you guys the whole setup and everything. We went from beginning to end through designing this circuit to actually doing the code for it and building the circuit and making it work. So I thought I'd like to show you guys just the whole thing, and it would be really cool if you guys could post videos of you guys actually doing this project yourself or whatever. But yeah, it's much more efficient to use a transistor than a lot of people use relays, which is actually not too bad of a way of doing it. But you know, relays, electromechanical, not the most efficient way to do it. They can fail, you know. Whereas here we have solid-state transistors. It's the most efficient way to do it. It uses pretty much practically zero energy, you know. Just have to drive the base of this transistor with very little current. By the way, this transistor is rated up to the voltage that we are doing. I don't know what the 3904 is rated for, but it's at least 30 volts. I think it might even be 60 volts. So it's rated to a lot higher voltage than we're working for. So you guys do have to be careful of the transistor you're using. Make sure that it is rated to the voltage that your garage door has across these two wires. So that's pretty much it for this one, guys. I hope you guys enjoyed this whole little tutorial, this rundown of a garage door opener through an Arduino. And like I said, I might go ahead eventually replace that Arduino with a Raspberry Pi. For those of you guys who do Raspberry Pi, we'll implement this whole same thing in Raspberry Pi, but I'm not very experienced in Raspberry Pi at all, so I really don't know anything about that yet. But I will try to get this same project going with the Raspberry Pi through a web browser. It'll be this exact same circuit, so none of this will actually change. The actual electronics will not change, but it's just that this platform that we're using, this Arduino and this Ethernet shield, will just be replaced all by the Raspberry Pi board here. But it's a lot different as to how we actually implement these, because this would probably run, you know, a web server, and it would actually, you'd have to have a script in there to run it, whereas this is just a bunch of C code and some libraries and stuff to make it work. But anyways, that's it for this one, guys. I hope you guys enjoyed it. Give it a thumbs up if you did. Subscribe to my channel. I hope you guys leave some comments and some feedback on these types of videos. Tell me if you guys like them or not. Tell me what I can improve on. Sorry if it's a crappy camera angle and stuff. I know I'm trying to improve it. You can see that I have a little $3 tripod here. So I've got a new camera. I'm trying to improve the quality of these videos and make them a little bit better. Trying to get a little bit better at this whole thing. But yeah, definitely leave feedback and tell me what you guys think of it. So that's it for this one, guys. And like always, have a good one.